Hello, everybody. Thank you for coming to the Informix Tech Talk by the IUG. I'm going to be talking about Informix SQL performance tuning tips that hopefully will help you out in your day-to-day work. Hope you enjoy the presentation. Again, thanks everybody for joining the Tech Talk on Informix SQL performance tuning tips. We'll get started. This webcast is being pre-recorded, and the slides will be available on the IUG website. Please mute your button, and we'll get started. And my name is Jeff Filippi. Company is Integrated Data Consulting. I do specialize in Informix consulting. Here's my email address and my website. And today, the overview, I'm going to be talking about using SQL Statement Cache to help your tune your Informix database. Review reads on tables, tracing SQL and Informix, using Informix HQ, SQL tracing, SQEXPLAIN tuning, use of PDQ and non-PDQ. So use SQL Statement Cache. You run unstat-g SSC. Look at the SQLs with a large number of executions because you want to look to see how many times SQLs are being ran. Saving even a second on an SQL statement that's executed a million times can make a big difference in your performance. So that's where you want to kind of look through and see, especially ones that are being ran a lot, you want to get the most performance you can out of each one. And also, we'll go over new features with Informix 14.10 for statement cache. So here's an output of a statement cache. Gives you the LRUs used, your current size, the max size, the pool size, the hits and the limit. And here you'll see the SQL statements that are ran. And then down by the bottom, when I highlighted, that's how many times that SQL has been executed since the system's been up or since you ran on stat-z. So those are the ones you want to kind of look at to see how many times they've ran, and then take that query that you see in there and then run it through DB Access. Run the explain plan on it to see if it's being optimized correctly, whether it's using the correct index or there's not an index on it, and so forth. The new there's with Informix 14.10, there's some new statement cache enhancements. They have some new sysmaster tables that coincide with the onstat-g SSC. And for more information, yeah, the links here that you can look at that information. You can now, with 14.12, invalidate specific statements in the statement cache. So if there's ones that, let's say the query's not performing the way you want, but you know that if you disable, invalidate the cache, it can give you better performance. Again, for more information on that, go to the link below. Also, you can now lock query plans in statement cache. So again, if your statement, if the plan, you want it to stay there and not be overridden in the future, that can help you out also. So you can also then dump the query plans from the statement cache. You can enable the statement cache query plan, 0 to disable and 1 to enable. It is disabled by default. It will consume more of your statement cache size. And the query plans are viewable in the SysMaster database in the SQLM query plan column. How do you invalidate a statement? You run an update statement on the SQLM table and set valid equal to 0, where the ID is equal value. You can then validate it by running onstat-g ssc and then look for the flag value, and it should show a DF, meaning it's disabled. So in the other case, you can lock the statement, again, by running an update statement, setting the lock equal to 1, where the unique ID equals a value. Again, you can then run the onstat-g ssc and look for the flag. In this case, it'll be showing a flag of F and L. Reviewing number of reads on tables and indexes. Use the table sysptprof to look at the buffer reads, the page reads, and sequential scans of the tables and indexes. Here's a select that I use a lot. It just does a select, the table name, the buffer reads, the page reads, the IS reads, and the sequential scans from the sysptprof table. Then I order them by the buffer reads descending to see which table or index is using the most buffer reads. Because there's a lot of cases that you think that the highest number of buffer reads on a system you think is being optimized, but it could be totally the opposite. It could be scanning a lot of unnecessary rows due to lack of an index, for example. Here's a case of the system of a client I was working on, and I saw there's one index and table that we're using a lot of buffer reads compared to the other ones. So when I looked at those, I went and reviewed the SQL statements that were being ran and found out there were some improvements to be made. So in this case, I ran it. In this case, by adding the index, it reduced the number of buffer reads tremendously. So from before, you had a lot higher number of buffer reads, and now after adding the index, it reduced them by quite a bit. So this will help improve your performance of your database by not having to scan so many records to get the results you need. Tracing in SQL and Informix. There's multiple ways to find information to tune in Informix and utilizing the tracing of SQL. The onConfig parameter, you can set the SQL trace value, so it'll trace the number of traces and the size of your trace buffer. You can also use the SQL admin API, and also you can look it through with Informix HQ. Again, tracing in SQL, there's a couple of ways to turn it on. The onConfig parameter mentioned below. Set the SQL trace. You can do off, low, medium, and high. You can set the number of traces, the size of each of the trace buffers, the mode, global or user. And then, for example, here's an example. You set SQL trace, set the level to low, the number of traces, the size of the trace, and the mode be global for all of them. So in this case, it allows me to trace the last 1,000 traces of statements of the instance. And also you can use Informix HQ to, again, set the tracing information. So again, in tracing SQL, improved SQL tracing with the SQL API in Informix, you can use these commands to manage SQL tracing. So you can change it dynamically. You don't have to shut the instance down. So you can either add a database, clear it, list the databases that are being traced, and then also remove databases to be traced. You can also suspend and resume all tracing at the server without deallocating the resources at any time. You run that by set SQL trace, suspend or resume. Here's how you enable tracing through the sysadmin database by running the command execute function task, and then say set SQL tracing on, your number of traces, your trace buffer size, your low, medium, or high, and then your global. To validate this, that the tracing is turned on, you can run onstat-g HIS. This option prints information about the trace SQL trace configuration parameter. So in this gives an output of all the traces that are in that say 1,000 number of traces. And it's a circular buffer, so it'll overwrite once it reaches that 1,000. So here's an example of the onstat-g HIS output. Again, it shows at the top your trace level, trace mode, number of traces, current statement ID, your trace buffer size, and the duration of your buffer. This shows how many seconds that it's being held in the buffer. So we're, in this case, was 8,241 seconds for the 3,000 traces. Also in the output, you'll see information about the actual SQL statement, the estimated cost, the estimated rows. It'll also give you the runtime. So from here, you can actually then determine how a query is performing. Again, here's some more information that it gives: the page reads, your buffer reads, your read cache, the number of execution times, the number of rows that returned any SQL errors or ISAM errors. You can also get information on the SQL tracing through the SQL trace table in the sysmaster database. I use this query quite a bit. So I do a select count from sysSQL trace where the SQL total time is greater than 2 seconds. So this will give me the number of queries that are running greater than 2 seconds. You can also say select, in the select, do a select star so you can see the actual more details about those queries and actually the query being ran. Another useful table is the sysSQL trace _ITER, which gives information in the form of an iteration tree for each of the SQLs. It allows you to identify which part of the query plan took the most time to run. Also, you can run the following SQL statements to get the SQL for the ones that have a higher runtime than half a second, kind of like I was just mentioned before. So here I'm selecting from the SQL runtime and the SQL statement from the SQL trace table where runtime is greater than half a second. And here's information from the sysSQL trace table. It gives you the ID, SQL ID, the address, the session ID, the user ID, finish time, the begin time, the run time, the pages read, buffer reads, and continues with all the buffer writes, caches, lock times, number of executions, your total runtime. And then down here it gives more about if there's any ISQL errors or ISAM errors. It'll give you the information about that. And then there's the SQL statement that it gives. You can also save the history of SQL tracing information in a table. Note, caution, when usually doing this, it can use up a lot of space quickly. I kind of went ahead and, in the scheduler, there's a new task called Save SQL Trace. The information is saved in the following tables in the sysadmin database. Mon SysSQL Trace gives you this statement, text, and profile. Mon SQL Trace Info gives you information, gives you statement tracing setup info, and then the Mon SQL Trace iter gives you iterations. Here's an alternative way to saving all trace information. So instead of getting every SQL you want, in this case, I created a task which saves SQL trace information for SQLs that have a runtime greater than 10 seconds. So this allows you to still trace SQL statements, but only show you the really long running statements. You don't necessarily care about the statements that took 0.001 seconds. You just want the longest running ones to help tune those. And then maybe once you have let your SQLs greater than 10 seconds, maybe lower that down to 5 seconds, and then maybe 2 seconds until you get your database SQLs tuned optimally. So here's an example of creating a kind of basically just copied information from the original table and created my own. So I created my own table to save that information, and then created some indexes so I could easily search on them quickly. Here's actually the information that needs to be inserted into the PH task table to activate the task. In my case, I was running it every minute. You'll want to see what the shortest time that your trace buffer is and make that frequency the task runs smaller than that. Using Informix HQ. Here we're going to show ways to use Informix HQ to look at SQL tracing. For example, here's a screen that shows SQL tracing, shows the status is enabled, the mode is global, level is low, the number of traces, and the trace size. So you can go also on the blue button up there, the SQL tracing, you can go click on that to actually change some of the configurations on the fly. And then on the right, it shows the tracing information when the tracing started, earliest trace in the buffer, duration of the buffer, and so forth. And then below that, you can actually see the types of statements that are being ran, the number of statements being ran for each of the different type of SQL statements, their max runtime, average runtime, the average amount of memory, and so forth. So you can then drill down on that to see the SQL statements. Then also in Informix HQ, there's under System Reports, there's an option there that says Slow SQL Statements. You can also click on that to review the 20 slowest SQL statements being ran. Now we're going to be talking about options available with SQEXPLAIN. The optimizer directive will void execute. generating query plans without executing SQL, for getting query plans for select insert updates, deletes, where data is being manipulated, but you don't want to change the data. And then examples of setting explain on to avoid execute in the SQL statements. So some of the set explain enhancements, you can turn off and on explain statistics through the onConfig parameter explain stat. So 0 disables it and 1 enables it. You could also set it with this following statement, set explain stats. When it is enabled, the inclusion of the query statistics section in the explain plan output file, it shows the query plan's estimated number of rows and the actual number of rows returned. So it gives you a lot more information. So here's an example on the bottom. It's in bold where it says query statistics. Gives you information about the table name, the number of rows scanned, the estimated rows, the true number of rows scanned, and the time and the estimated cost. Dynamically set and explain. So when you want to look at a query, a session that you want to run, you can set on mode-y, the session ID, and 0 for off and 1 for on. It'll write to a file called SQEXPLAIN.out and then the session ID appended to it. With Informix 11, there is a couple changes. Additional value 2 allows you to get explain without statistics for a session, display the query plan only. Also, you can specify the file name and directory that you want to write the explain output to. This is a great feature to allow you to see SQL statements executed in the explain plan for each of the SQL queries, for SQL statements. Again, make sure you only have this turned on for a short period of time, as it creates a large file on a busy system. So again, more information about SQEXPLAIN output. Add the set explain on before the statement you want to examine. You can specify the directory that you want the file to go to. For example, set explain on file and then file in the directory. And you can review that output from the file you put it in. And for Windows, look for a file name called username.out in the directory SQEXPLAIN on Windows. And Unix and Linux, it'll be in the directory that you ran it from. So some of the set explain output, you have a query displays the executed query and indicated whether its set optimization was low or high. Any directives that were followed, there would be listing the directives followed for that query. Estimated cost is the estimated amount of work for the query. And the number doesn't translate into time. It's only comparable to same queries, not of other types of queries. And then estimated number of rows returned. This is an estimate of the number of rows returned based on the information from the system catalog tables. Also, you have a numbered list. This is the order in which the tables are accessed, followed by the access method, either index or sequential scan. Then you have the index keys, shows the columns used as filters or indexes, and then the query statistics is enabled the onConfig parameter explain stat. So I'm going to be showing some examples of explain plans. The following slides will show some tuning of SQL based on the following scenarios. Using functions that cause an index not to be used, criteria from views causing sequential scans, using in causes sequential scan, use of directives, use of substring inquiries, use of functions and queries, and use of a better index, creation of a new index. So in this case, we had a query to clients. We had a function that caused an index to not be used. So when we first ran the query, this query was taking like 20 minutes to run. And I was looking at it, and all the data showed in the from clause that they all had indexes on the fields, but we were still getting sequential scans. And as you can see in the bold here where it shows the upper, it's using a function upper on the invoice ID. And that actually was what was causing this to use a sequential scan instead of an index scan. So what we did is that we were able to take out use of the word upper and actually use its fields. So that way it was actually able to do an index scan on that table and improve the query quite a bit. Another way that you can do it is to add a function which converts a character to all uppercase and change the index to include the use of the function. So here's the actual function that I created. Just create a function, character field, the size of 20, defined it, and then we converted that character field to an uppercase. Then we created a new index which used the upper function for the invoice ID. And that again helped for the query the performance go from 20 minutes down to 5 seconds. Here's another query criteria used to select from views that caused sequential scans. So again, I was looking at this query and all the data was there and it looked like it should be running fine, but we were getting a sequential scan. So in this case, what I like to do is in the query, I like to start commenting out parts of the where clause to see if by doing that, I'll get a different result. So in this case, I commented out the last column before the ordered by because it was doing a quantity. And once I did that, it was using all the indexes. So I'm like, that's strange. I wonder why it's doing that. Well, in this case, is that there was a view being used and the CM quantity on hand was being calculated from that. That was causing the sequential scan. So we went ahead and changed that. We were able to comment that out, and in the code, we rewrote it so it wouldn't have to do that function of that query. Another one is using an in clause causing sequential scans. So sometimes if you have a large number of values in a where clause or in value, in this one case, I kind of simplified it, but a client that had 50,000 values in the in clause, and it took a long time, a lot longer for it to run than it should have been. So it was performing a sequential scan on that. So the resolution was to add a couple new indexes and then change the query to use an or instead of an in. And that helped speed up the query quite a bit. And then here's another resolution to criteria using in the clause for sequential scan. Sorry, this should be in order. So here we're selecting from the table where value equals different values. So again, in here it's doing an index scan, but it's not on every table. So it's taking more time. Go back, sorry. Sorry, I think I missed a slide in here, but it's supposed to be showing the query where when we split them up, it ran the index correctly. And here's the use of directives for the queries. In this case, I was trying to tune the SQL statement to get the results I wanted, but any combination of changing things, adding indexes, and so forth wasn't working. So the only option I had was to force it to do the optimizer the way I want it to. So in this case, we had estimated cost of $57,000, and the first part of the index wasn't the most optimal way that I wanted to use. So in this case, we use an ordered directive to force it to give the best optimal plan. So here you can see that the order directive was used and the query ran a lot quicker, even though the cost was higher than the original cost. So sometimes when you're looking at the cost, you have to look at based on that query when you're tuning it and not compare it to other queries, because other queries can give you different costs. So here was the case where we changed this part of it to run faster. Also, next we're going to talk about using substrings, the best index not used. So in this case, they had a query that had all the fields in them that was used in the index, but it was still not being optimized correctly. This one field in the highlighted part was the part that was causing the issue. So by changing that query to use matches instead, gave us a lot quicker performance for the query. Now we're going to talk about use of functions in queries that cause specific indexes not to be used. So in this case, I've highlighted here, this query was taking about 20 minutes to run. And the issue is that they were using the extend function in the date field. There's a lot of times if you use any types of functions in a where clause like this, it'll not use the index. So for example, here it was used as a filter and not in the actual index field for the query. So it caused it to run a lot longer. So what we did was to get rid of the function for the extend, because they were looking for a day, just a 1 day range. So we changed it, so we used the create TS field, where it's greater than or equal to the beginning of the day and less than or equal to the end of the day. And the original cost was $546,000, and after changing it, it was down to 2. And again, this query went from like 15-20 minutes down to like 1 second. Made a big difference. And also what we did was, in that same query, we added another index to improve the query. So now the create TS field is on the first column of that index, which made it run a lot quicker. Here's a case where you have to look to see if there's a better index to use versus what's out there currently. So again, in this case, we were looking for the timestamp was the best case to use, but the index was using the purchase type code. So we went ahead and then added an index on that create TS purchase type, and it improved the performance of the queries tremendously. Now you can see in the index keys, it's using that index. Subqueries that cause queries to run slow. I've seen this in many client sites I've been at. It's easy to write the query without thinking about how it actually would be joined. So for example, here's a query we're selecting from a table where you have some between the date fields, and then you're looking if a document number exists in another table. So initially, when we ran this query, it took about 20 seconds to run. By actually making one little change to the subquery, we added in here, we're adding the document number from, we're saying for the in field and what's in the select. By doing that, instead of scanning the whole table over and over to try to find it, you're using the index scan to do it. So this type of change, take a look to see if you have any of these types of queries, because they can be improved by quite a bit by adding that to your subquery. Now we're going to also be talking about methods for improving SQL performance using multi-index scans, utilizing temp tables which have large in clauses, utilize PDQ query, utilize DS non-PDQ query mem. So multi-index scans. With multi-index scans, if you have a query that has multiple criteria in the where clause, and you have indexes with those columns, the optimizer can utilize multiple indexes at once to improve the performance of the query. So in this case, we had a query where we're selecting from a table where a bunch of or clauses and a date field in there. Well, it's actually performing a sequential scan on this query. So here it was taking 3 seconds to run, which may not seem like a lot, but if it's ran a lot of times, it can make a big difference. So here were the current indexes on the tables. And then when we looked at it, there was one or field that did not have an index. So by creating that index, which was this field, it now returned a lot quicker. It's now using an index scan on that field. So since all of them are now having index, the query finished instead of 3 seconds, took 0.02 seconds to run. Using PDQ priority in DSS type queries. PDQ can be a very powerful feature. You have to make sure that you're running it only on DSS type queries and not OLTP type queries. Because if you tried to do it in OLTP type queries, you can thrash your database and cause major performance issues with it. So you really want to just do PDQ priority on large DSS queries. Maybe if you're running like an HDR server where you're doing large reports on it and so forth like that. And so you set PDQ priority to 100. You also a lot of times want to have, when you're doing this, is fragmented tables so that the PDQ, you can scan multiple threads at once. So in this case, we had this table has 3 threads running, meaning there was 3 fragments that were able to run for it. Utilize DS non-PDQ query mem. I still see a lot of people that do not use this parameter. It's a very powerful tool to use for non-PDQ type queries. Again, setting this query correctly can help improve your non-PDQ query by a lot. What it basically helps is that it allows you to perform sorts in memory instead of on disk. To correctly set it, you need to set DS total memory to a value and then set DS non-PDQ query mem to up to 25% of what your DS total memory is. And then here's, for example, if I had set DS non-PDQ query mem to 50,000, then shows the sort memory buff that it's using. Yeah, so here's where it's not using it, and then here's where, sorry, this is where it's using it for its 50,000. So it's using some of the memory. You increase it to more, it'll actually use even more of the memory if it's available. And one example for us at one client, they had a case where by increasing DS non-PDQ query mem from 128, which is a default, to 50,000, the query, without doing no other tuning to it, the query time for this specific query went from 2.5 seconds down to 0.25 seconds. And also the wait on IO from top went from 2% to basically 0. So this, again, we're not talking about changing queries here. We're just talking about giving it more memory to utilize, which can make, in this case, be a tremendous difference, about 90% improvement in performance. And in summary, talked about using SQL Statement Cache, reviewing reads on tables, tracing SQL and Informix, looking at Informix HQ and SQL tracing, SQEXPLAIN plans, tuning, and use of PDQ and non-PDQ. Any questions? Thanks for your time.